Okay, good evening, ladies and gentlemen, folks. Thank you for coming. My name is Suherman. You can call me Alex, for simple one. I'm a third-year DPhil student in physical and theoretical chemistry. Now I'm presenting you my research progress, focuses on electrochemistry of heavy metal ions. First of all, have you ever imagined that heavy metal ions such as arsenic, mercury, thallium, aluminum, and so on, including organic toxic compounds such as cyanide, is very dangerous, harmful for living organisms, not only for human but also for the environment. So, for example, if this heavy metal ions present in the drinking water, food and drug products, in very small dosage, for example, mercury, the WHO, World Health Organization, has declared that the minimum permissible level for mercury in our drinking water is about 10 to 20 nanomolar, or about 200 parts per billion. If you consume it, it will lead to the carcinogenic effect into your body. So, as a chemist, it's a good challenge for us how we determine either qualitatively or quantitatively to analyze the presence of this unwanted substance. That's why electrochemistry facing nowadays serious challenge to support healthcare and also for the development for the wellness for the society. Maybe you know that United States has put the logo in their money, "In God We Trust." For electrochemistry, there's like a flamboyant logo that in voltammetry, in electrochemistry, we trust. Why this voltammetry techniques in terms of electrochemistry is a powerful technique to detect this unwanted substance for the living organism. So electrochemistry is a branch of chemistry, especially physical chemistry, that related to the current and charge at certain chemical reactions. So when the chemical reaction occur, the kinetically and thermodynamically will lead to specific electron loss or electron gain to the system. So for electron loss, it's simply defined as the oxidation process, and if the system gain the electron, it's simply defined as the reduction process. Sometimes the process can both oxidation and reduction, so we call redox process. But somehow, for some niche application, we just want to oxidize the material or reduce some material for a certain purpose. First of all, this is my first paper. It's almost 100 scientific paper. We summarize the recent advance for voltammetry. So in fact, there are various analytical methods to detect heavy metal ion or any organic compound in our daily life, such as atomic absorbance spectroscopy, high performance liquid chromatography, XRF, XRD, and so on. But this conventional method suffer from very serious problems, such as the big analytical device that's always available in the laboratory, so you cannot bring out for the in-situ application or in the remote area, or even you cannot put it in your pocket for to check the presence of the heavy metal ions or organic compound. Also, they are suffer with matrix interference. You know, naturally, maybe many others organic compound can make a complex with the system, so it will be difficult for this conventional analytical method to determine specifically what we want to detect. That's why electrochemists try to find the new alternative method that user-friendly, so even untrained person can operate this analytical device and can bring it for the remote area and for in-situ application. Also rapid analysis quickly, maybe in seconds you can know the dosage of these heavy metal ions, and also maybe relatively inexpensive. Inexpensive analytical device doesn't mean or correlated this is poor poor quality. But we want to, as much as possible, this product can be used for untrained person for their daily life. So for example, this is my second paper, when we talk about detect the heavy metal ions such as inorganic mercury, Ag2+, in an aqueous solution. The method is very simple. You just drop gas nanoparticle, for example, silver nanoparticle, in the electrode surface, and then you immerse into the system that containing inorganic mercury. So, by the galvanic displacement process, when the mercury attacks the silver that deposited in the surface, it will correlate that when the mercury is increased, the silver nanoparticle will decrease by replacing the compound with each other. So the gap, the concentration gap, when the mercury attacks the silver is correct how much mercury is present in the system. Because the current and the charge relative from the voltammetric system, we can calculate the concentration of this compound. Next, this is my third paper, talking about how we detect aluminum using chelating agent that present in the surface of electrode that contain tannic acid. So the idea is we have gold nanoparticle kept with tannic acid. This is organic molecule that contain many phenolic compounds. And this phenolic compound, when we oxidize using the specific current and specific potential, can oxidize and leaving like a radical compound which is able to make a complex chelating with the specific metal. For example, aluminum, like a complex, and this system correlates to the resulting two peaks. First peak corresponds to the oxidation of this molecule, and the second peak occurred because the complexation process. So the second peak, we can calculate the charge as the result from the current and potential, and from the first Faraday law, we can know the concentration of this unwanted aluminum present in our products. Another voltammetric technique, my fourth paper, during my DPhil, we also want to detect mercury in the same system. So what's the difference between previous one? We have same material, gold nanoparticle kept with tannic acid, but the first one to detect aluminum and the second one for mercury. It's a very unique system because when you apply specific starting potential, for example, this one, you start from 0 to 0.7 for the oxidation process. You can find second peak here at about 0.54 that correspond to the oxidation of the complex. But when you apply different potential window from 0.3 to 0.7, you can find the second peak occur at different potential window. And this is specific only for mercury. So in one system, when you apply different condition, different starting potential, different accumulation time, also different scan rate, how fast you scan this current, it will lead at different position for specific metals. So you can detect in both ways. So mercury, aluminum, mercury again, and next we talk about zinc. This is my five paper about zinc. Same process, but we want to try to detect in single particle level. So the idea is we call nano impact. The first one, we talk about bulk condition in the macro system, and now in the single particle level, how gold nanoparticle or silver nanoparticle can react with single particle of zinc. And then, by applying specific potential, again, the keyword is potential, you can find specific concentration for zinc. And interestingly, we also can find this zinc either in oxidation or reduction process that follow Langmuir absorption process. It means that the reaction is surface control. Okay, in electrochemistry there are two systems. It's a surface control process which leads to the absorption of unwanted chemical to the surface, and the second one is diffusion. For the diffusion one, it's very complicated because we talk about kinetic and thermodynamic effect, and that's why it will have to long pre-treatment process to find the specific method or protocol to selectively only for Z. Next, it's about organic compound we call cyanide. Again, with the specific control, different condition, we can find the detection of the cyanide in single particle level. So we talk in not only in nano, but in single atom, how the nanoparticle can react each other with unwanted chemicals. So this is my electrochemistry group, and next, the next project for me is how I can able to detect in complex media, not only for single molecule, but also with various molecule, and very selective for many heavy metal ions. I think we missed some slide here, the new one. We talk about the industry 4.0 nowadays. So the challenge is how we can synthesize specific material that powerful for detection these unwanted chemicals by wearing like disposable, not only disposable chemicals, but also attached to the human body, and we can bring for our daily life. So even in our mobile phone, we can check the concentration of these unwanted species. Thank you so much for your attention. I think that's all. Thank you. Next speaker.